Hello everybody, welcome back to another lesson. Today is going to be the last lesson for our steam boiler model. And here, all we're going to do is adjust some things and also fix some things. So, the first thing we're going to fix is, well, let's show you first. So, let's go to shading. Mine's gonna take a while to load, and I will show you the problem. Okay, it's done loading, and well, did you just see that? So the bubbles are wobbling, but look, it just randomly stops. Yeah, see, and that shouldn't happen. It should keep on going forever. Well, yeah. So we need to fix that. So let's add a helper function. Oops. Let's call this add cycles repeat. Add cycles repeat. And now the parameter object paths. Paths, if you remember, you can, if you go down to one of the insert keyframe things, you can find data path. Let's see. Okay, over here, yeah, data path location. So we're changing the location in that. So yeah, data path is also going to be location for this one. And the final parameter is going to actually. Do we need to add parentheses? I'm going to try adding parentheses. We might need to add parentheses around this. If we add parentheses, I think you need this as well. Interpolation method is linear, is our final parameter. What is interpolation method? And I'm going to tell you. So interpolation method linear means that the change of key between two keyframes is the consistent. So it's not like it doesn't keep accelerating. It doesn't accelerate when you move from one keyframe to another. Like the rate that it goes to the keyframes is the same. Okay, now let's continue. So loop animated data pass on an object. So location, scale, things like that. So yeah, we just loop the data path. So the location of the data path is how big the bubbles are. For path in path, so location. For FC in obj.animation data.action.fcurves. Here's another term you might not know, fcurves. Let's finish this block of code, and then I'm gonna explain everything. fc.data path is, if it's equal to path, then mod fc.modifiers.new type equals cycles. Mod.mode before is repeat. Mod.mode after is equal to repeat. And fcurve is well, like a representation of how an object moves at any keyframe. So we're using the cycles modifier to keep repeating those things. And that's it for this step function. Now it's time to use it. So where do we use it? Well, let's go down to the wobbles, the places where the wobbles are, because here we're going to use our the function that we defined to make the bubbles repeatedly. Wait, actually, let's do this over here first. So because I also want to repeat the water going down and back up. Add cycles, repeat, nt, and then this is our data path, nodes, same thing, split gt dot input 1, I think I accidentally pressed something. 1, and then default value, frame, wait, no, I was copying the keyframe insert thing. We don't need, that's it, we don't need anything else. Yeah. And now let's add it again in the bubble place. The place where the bubbles are. So which part makes the most sense? Is it over here? Over here? Or over here? Okay. So in the first stuff function, well, this is just the equation for the wobble driver. It won't make that much sense if we put the cycle repeating thing in the equation. I mean, I guess we could. No, never mind. Yeah, we can't. Okay, now let's look at this part, random wobble. Well, this function just makes it so that it has random, the way all the individual bubbles wobble are different. See? So it has to be the object prefix. Now, add wobble to prefix, which just, you see, for object and BP data objects, just uses the random wobble to like, create the curving thing. So this is where we should there are things. Add cycles, repeat, double, location, scale. Because, well, the bubble is our object, and location and scales are our paths, because the size are also different. Remember, because it changes its size. Yeah. Wait, actually, yeah. Sorry, I thought my brain was blanked out. It's not this one. It's this one. Add bubbles, because this just applies the wobble. and we don't want to play the level infinitely because it's over here. Yeah. The add bubbles because we just want to keep adding bubbles, keep having them come in, and then we'll change the location and the scale. Okay. So now let's try that. Okay, let's see. Do we want this? Okay. So we missed something. Let's try to think what we missed. So we have everything. We added the cycles. Add cycles repeat in the correct places. So over here and over there. So let's see what we missed. Is it up here? I'm gonna double check. For path and paths, mod, touch mode. After, okay. So the problem is where that this is supposed to be FC not F, and then at the bottom here I put the location, the comma inside the location, but now it works, so it's fine now. Okay, so the last thing we have for this is the camera, because we want to render it, but we don't have any camera, because to render it, well, we need to know the angle. See, I'm just pressing the camera view, but nothing's happening. So that's obviously because there's no camera view. So let's make a camera view. Alright. Position B is going to be the name of the camera position. It's going to be vector 0, -5, and 4. So it's going to have 0 on the x, so in the middle for x. It's going to be -5 for y, so it's going to be out like that, and then 4 at the top, so it's going to be facing it like that, so I can really get to see the whole thing. Next, speedfly.ops.object.camera add. Location is position B. Rotation, we don't need to rotate it because it will automatically face the target. Scene.camera equals bpy.context.object, so yeah. Camera add, not camera add. Now, def angle camera. Angle camera. Angle camera. Angle camera. Camera. It's going to be position, the parameters, so we have used angle camera before. It's just going to find a good angle to be able to get the thing we need. Position, camera, names of target objects. I take the names and the position of the camera. PTS, the points, is bpy.data.objects, and that location for and in names of target objects. Minimum C is vector, min p.x for p in points, min p.y for p in points, min p.z for p in points. So the max, so the minimum that you can for all the coordinates. So the minimum, yeah, the minimum coordinate for the coordinates. And you can do the same thing for max. So max, and then just make everything max. Max p.z. Okay. Now center B equals min plus max times 0.5. Return rotation camera. Names is equal to outlet V2 lower drum. Scene dot camera dot rotation Euler is equal to angle camera position B in names. So the names are going to be outlet V2 and lower drum. So this, and then one, I think it's like this. So we want it to be in somewhat in the middle of here. The angle to be somewhere over there, and then we use the angle camera to make the rotation. So center rotation cam. Oh wait, I forgot to define rotation camera. Rotation camera is equal to center B minus position the camera dot 2 track quat negative Z negative Y dot 2 Euler. So we convert quaternion, which is like a more complicated rotation thing, to 2 Euler, which is more understandable. And then rotation camera, you take the center B, so the center of all the points with the x, y, z, and then so the center of all the points for the two objects, and then find the middle point. Then use 2 track quart, then 2 Euler to get a good angle of the camera to capture what you want. Now we have a camera view. You can see it doesn't capture the whole thing, so maybe we can make it go out a bit more. -8. Let's try -8, and see, now I can capture much more. So you can adjust the camera however as you like. And that's it for the steam boiler. We'll see you in the next model. Bye.